Hello and welcome. We're Team 4. Our data consisted of two files, tracks.csv and artist.csv. We decided to merge the two data sets because we felt that artist popularity could be a very important variable in predicting business success. The tracks data has a little over 586,000 observations, and the artist data has a little over 1.1 million observations. Each track or observation in the tracks dataset could have up to 59 artists. After some analysis, it was determined that the vast majority of tracks with over 10 artists didn't have high popularity scores of 50 or over, which was our measure of business success. Therefore, we concentrated on the artist popularity scores of up to the first 10 artists on each track. The scope of this analysis was to merge the two datasets, clean and standardize the data, determine business success, divide the data into training and testing sets, train our model, and assess its performance. We are unable to do a forecasting model in this instance as there's no time series element to this data. We determined that business success should be track popularity of 50 or more. Our variable correlation analysis showed that artist max popularity, energy, loudness, and release date are all correlated to business success. Artist max popularity is the popularity score of the artist on the track with the highest popularity score. Some tracks have up to 59 artists, therefore measuring the popularity of each artist on every track wasn't feasible and likely irrelevant, as we found that very few tracks with over 10 artists had high track popularity scores to begin with. Acousticness measures how acoustic in nature a track is. Loudness, as implied, is the measure of how loud a track is. Energy represents a perceptual measure of track intensity and activity. We split the data into training and testing sets with a standard 80-20 split. Our regression model showed to be statistically relevant as all variables have low p-values. Data showed that for every 1 unit of artist max popularity, there is an increase in track popularity of 72%. Energy increases track popularity by 91%, loudness by 23%, and acousticness decreases track popularity by 69%.
Once we have completed to train the regression model and obtain the business insight, we test it using the remaining 20% of the data to verify its accuracy. Looking at the confusion matrix on the left, we can observe that the model achieved an impressive overall accuracy of 88.8%, demonstrating excellent performance in detecting true positive prediction. We also constructed a decision tree to identify pivotal factors that contribute to business success, which in our case is the track popularity. Our findings revealed that the artist max popularity serves as the initial checkpoint. Tracks with a value below 57 are unlikely to be popular. For the remaining subset, loudness became the turning point. Interestingly, we can observe that the artist max popularity has a more significant impact compared to the other feature. This slide shows a better view of the decision tree model. After testing the decision tree model using the remaining 20% of the data, we achieved an outstanding overall accuracy of 89.5%. The model showcased an excellent performance in detecting true positive prediction, while its efficiency in identifying true negative was comparable to the regression model.
The scope of this analysis is to provide business insights based on specific features using the extensive number of variables provided. The tracks dataset offers a song popularity index, while the artist dataset contains each artist's popularity index. Our hypothesis was that the artist popularity, along with other descriptive attributes about the tracks themselves, are decisive factors in determining a track's success, and this proved to be true. To create a comprehensive data set, we created new variables in the tracks dataset, and we encountered some complexities when dealing with tracks with multiple artists. Our hypothesis was proven to be correct and corroborated by the logistic regression and decision tree models. Additionally, we'd like to mention that a forecasting model couldn't be utilized in this specific study, although that would have been very interesting. The data includes release dates, However, they couldn't be treated as a time series. We are all aware that older songs can achieve high popularity even after some time. This can occur as a result of remixes, utilization in the cinema industry, or being featured in special high visibility events. Or maybe it's just that an artist has a lot of fans. Thank you for watching.